Hello. Please hit like button and subscribe my channel. Also press bell icon for future video notifications. Thanks.
The 10-year anniversary of the Fukushima Daiichi nuclear accident occurs in March. Work just published in the journal Science of the Total Environment documents new, large 300 micrometers, highly radioactive particles that were released from one of the damaged Fukushima reactors. Particles containing radioactive cesium 134 plus 137 Cs were released from the damaged reactors at the Fukushima Daiichi nuclear power plant FDNPP during the 2011 nuclear disaster. Small micrometer-sized particles known as CsMPs were widely distributed, reaching as far as Tokyo. CsMPs have been the subject of many studies in recent years. However, it recently became apparent that larger 300 micrometers Cs containing particles, with much higher levels of activity, approximately 105 becquerels, were also released from Reactor Unit 1 that suffered a hydrogen explosion. These particles were deposited within a narrow zone that stretches approximately 8 km north-northwest of the reactor site. To date, little is known about the composition of these larger particles and their potential environmental and human health impacts. Now, work just published in the journal Science of the Total Environment characterizes these larger particles at the atomic scale and reports high levels of activity that exceed 105 becquerels. The particles, reported in the study, were found during a survey of surface soils 3.9 km north-northwest of Reactor Unit 1. From 31 Cs particles collected during the sampling campaign, 2 have given the highest ever particle-associated 134 plus 137 Cs activities for materials emitted from the FDNPP, specifically, 6.1 times 105 and 2.5 times 106 becquerels, respectively, for the particles, after decay correction to the date of the FDNPPA. The study involved scientists from Japan, Finland, France, the UK, and USA, and was led by Dr. Satoshi Utsunomiya and graduate student Kazuya Moroka, Department of Chemistry, Kyushu University. The team used a combination of advanced analytical techniques, synchrotron-based nano-focus X-ray analysis, secondary ion mass spectrometry, and high-resolution transmission electron microscopy to fully characterize the particles. The particle with a 134 plus 137 Cs activity of 6.1 times 105 becquerels was found to be an aggregate of smaller, flaky silicate nanoparticles, which had a glass-like structure. This particle likely came from reactor building materials, which were damaged during the Unit 1 hydrogen explosion. Then, as the particle formed, it likely adsorbed Cs that had been volatilized from the reactor fuel. The 134 plus 137 Cs activity of the other particle exceeded 106 becquerels. This particle had a glassy carbon core and a surface that was embedded with other microparticles, which included a PBSN alloy, fibrous Al silicate, Ca carbonate, hydroxide, and quartz. The composition of the surface-embedded microparticles likely reflect the composition of airborne particles within the reactor building at the moment of the hydrogen explosion, thus providing a forensic window into the events of March 11, 2011. Utsunomiya added, the new particles from regions close to the damaged reactor provide valuable forensic clues. They give snapshots of the atmospheric conditions in the reactor building at the time of the hydrogen explosion, and of the physiochemical phenomena that occurred during reactor meltdown. He continued, whilst nearly 10 years have passed since the accident, the importance of scientific insight. Cleanup and repatriation of residents continues, and a thorough understanding of the contamination forms and their distribution is important for risk assessment and public trust. Professor Gareth Law, co-author, University of Helsinki, added, cleanup and decommissioning efforts at the site face difficult challenges, particularly the removal and safe management of accident debris that has very high levels of radioactivity. Therein, prior knowledge of debris composition can help inform safe management approaches. Given the high radioactivity associated with the new particles, the project team were also interested in understanding their potential health dose impacts. Dr. Itsunamiya stated, owing to their large size, the health effects of the new particles are likely limited to external radiation hazards during static contact with skin. As such, despite the very high level of activity, we expect that the particles would have negligible health impacts for humans as they would not easily adhere to the skin. However, we do need to consider possible effects on the other living creatures such as filter feeders in habitats surrounding Fukushima Daiichi. Even though 10 years have nearly passed, the half-life of 137 Cs is approximately 30 years. So, the activity in the newly found highly radioactive particles has not yet decayed significantly. As such, they will remain in the environment for many decades to come, and this type of particle could occasionally still be found in radiation hot spots. Professor Rod Ewing, co-author from Stanford University, stated, this paper is part of a series of publications that provide a detailed picture. This is exactly the type of work required for remediation and an understanding of long-term health effects. Professor Bernd Grambo, co-author from IMT Atlantique, added, the present work, using cutting-edge analytical tools, gives only a very small insight in the very large diversity of particle. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.